guys, it's me. Today we're going to talk about area and perimeter. I'm just going to give you some definitions about what area and perimeter really are. So the definitions of perimeter is the distance around a polygon, so around the outside. Area, the number of square units needed to cover a given surface. So this is measured in square units, and imagine that we're covering something. So if this was an image of my garden and it's got some weeds in it, the perimeter would be the fence that I would need to put around my garden. So it would be the outer fence here. So if I fenced in my garden, that would be what the perimeter stands for. Some units that we use perimeter are feet, meters, inches, centimeters, and yards. There are many other ways to measure items, but those are the most common and the ones that we'll use in class. So area is the grass that is covering my garden. So if we pretended that my garden was full of grass, it was all filled in, I did a good job covering my garden with all this grass, that is what area is. It's everything filled in. It's that space covered up. So the units that we will use are feet squared, meters squared, inches squared, centimeters squared, yards squared. So it's whatever the units are, but we are measuring it in square units because we've got more than one dimension going on. Some formulas to memorize. You've got to memorize these. The reason that you really need to memorize these is because we're going to be using them over and over and over again. So instead of having your homework or your classwork take forever, if you know it and you memorized it, then you can recall it really fast. And so what might take you 45 minutes then takes you only 15. So we need to memorize them. Plus, we aren't going to be doing basic problems like these. We're going to be doing some more complex problems. So in order to not get frustrated with the big complex problems, let's master the easy, simple formulas so that when we get to the next step and it becomes that much harder, we already know at least our foundation. So if we know these formulas, we can kind of guide ourselves in the right direction when it becomes harder. So our first two formulas we need to memorize are the formula for the area and perimeter of a square and area and perimeter of a rectangle. So just some characteristics of a square. A square is made up of all right angles and all the sides are congruent. So you see in my picture here I've got 4 right angles in green and then I've got 4 orange dashes on the sides. Those represent congruent sides. They all have one single dash, so that means they're all congruent with each other. So to label my side, we're just going to use an S for square, for squares only. S. So the formula for finding the area of a square would be to take that side measurement and square it. Pretty easy, right? So if I've got a square here and I've got it only gives me one side length of 5, then that's what I use. And this, guys, is how you're going to be doing your problems. You take the formula and you take your information from the problem and you literally substitute in that information for what it stands for in the formula. So if my side length is 5 centimeters, then inside the formula, instead of S, I'm replacing it with a 5. Then I can evaluate using order of operations. Here I've only got one operation, pretty easy. So I just calculate 5 squared, which is 25. Every answer needs to have units. In this case, my units were centimeters, and remember with area, it's centimeters squared, because I got the square units. Perimeter is a little bit different. Perimeter is just the outside distance, so it would be easy just to add up all the sides here, but with math we like to find shorter ways to do things. Instead of trying to add 5 plus 5 plus 5 plus 5, let's just use this formula P equals 4S. That means I've got 4 sides, they're all the same length, so whatever that length is, I multiply by 4 and I'm done. So in this case, I would multiply 4 times 5 to get 20. And for perimeter, remember my units are just centimeters. So whenever you're inserting a number into a formula, whenever you're using substitution here, like I substituted at 5 for S, you're going to want to use parentheses or a multiplication symbol. Here, there is no multiplication symbol. When a number and a letter are side by side, that automatically means multiply. But when I use substitution and I'm trying to show multiplication between these two numbers, I've got to represent it somehow with a symbol. Because if not, my number would just look like 45. It's not 45, it's 4 times 5. So I've got to represent either with parentheses to show another way of multiplying or by using a dot, which I do down here. But anyways, that's how you find the area and perimeter of just a square. Rectangles. Some characteristics of rectangles. They have 4 sides and all 4 angles are right angles. And then here we've got the opposite sides are congruent here. So I put 1 dash to show that these opposite sides are congruent. And then over here I've got another set of congruent sides, but they are not congruent to the other pair of congruent sides. Hope that makes sense. I think the picture speaks 1,000 words there. We're using length and width. So the formula for finding the area of a rectangle would be length times width. Again, in a formula, you can have 2 letters that are side by side with no operation symbol between them, and that will automatically mean to multiply. When I substitute in my values into the formula, I have to use a multiplication symbol or else it would just look weird. So I've got to put in that dot to represent 15 times 4, and that's 60, and I always have to remember to put my units meters squared. Perimeter, we've got a different formula than the square formula, and it's kind of fancy. What this states is perimeter is equal to 2 times the length plus 2 times the width. The reason that this formula works is because if you look at the rectangle, again, these 2 sides are the same and these 2 sides are the same. So instead of saying, oh, 15 plus 4 plus 15 plus 4, we try to shorten it a little bit. And we can say, oh, I've got 2 15s and 2 4s. How much is that all together? So I've written it here, and I've used parentheses this time to separate my multiplication. And I inserted 15 for L and 4 for W. 2 times 15 plus 2 times 4. Well, I've got 3 operations. I've got 2 multiplication operations and 1 addition. So what that means is I've really got to think back to my order of operations and make sure I'm following them in order. In this case, my multiplication is going to come before my division. So I can multiply these 2 simultaneously, and that's okay. 2 times 15 is 30, 2 times 4 is 8. Then I finish off with my addition. My final answer, 38 meters. Those formulas should be the easiest. Now we're getting complicated because we've got like diagonal sides and slanted things. So you might not remember all these from elementary school, but it's important, and we're going to really use these a lot. So the next formula to memorize is a triangle. A triangle is made up of 3 sides. There are different kinds of triangles. The right triangle is probably the easiest to work with because the information we need to get from a triangle basically is its base and its height. That's kind of the most important information for us. In a right triangle, the base and the height are already present. They're already there. You can see them pretty easily because of the right angle. In a triangle, the height and the base come together to form that right angle. If you don't have a right triangle, for example, an isosceles acute triangle, and you're trying to figure out, well, where's the height? There's going to be either a dotted line or a solid line that drops down through the top of your triangle all the way to the bottom of the base. Like I said, it's going to be either dotted, it might be a solid line, but the thing that you will know that kind of alerts you that, hey, that's my height, is that the height forms a right angle with the base. That's very important. So, because we're going to look at some triangles that are twisted all different ways, and you're going to need to find the base and the height. Well, just know this, guys, the base and the height come together to form a right angle. So wherever you see that right angle, you've got your base and your height. Okay? So the formula to finding the area of a triangle is you're going to take 1/2 times the base times the height. Or some people have memorized it, base times height divided by 2. Both ways work. So if I've got my triangle here, looks like I've got an isosceles triangle. The reason I know that is because I've got these 2 orange dashes. Remember, those dashes mean that these 2 sides are congruent. So I've got a side of 9 yards, and that means this pink side over here will be 9 yards also. I've got a base of 10 yards and a height of 7 yards. So sometimes you have to really look at the picture and figure out what's happening because there's a lot of information, there's a lot of symbols. So I only need for area the base and the height. So I'm going to, once I have my formula, I'm going to substitute in my values into the formula. I'm not just going to plug all those numbers in my head and spit out an answer. That's not okay. We need to practice substituting in our values into our formula. Because like I said, when these problems get really complicated, really large, you're going to be glad you did. So I rewrote the formula with my values inserted, 1/2 times 10 times 7. I could multiply 10 times 7 and get 70, and then multiply that by half and get 35, which is what you see over here, which is the same thing as right here. Or I could do half of 10, which is 5, and 5 times 7 makes 35, which either way will work. But no matter what I do, I need to make sure I have my yards squared for area. Over here with perimeter, there's not really a fancy formula for finding the perimeter of a triangle. We just need to know that it's side 1 plus side 2 plus side 3. So I'm just adding up all the sides around my triangle. Now here's where the important, these congruent sides come into play. To find perimeter in this triangle, I'm not using the number 7 at all. The 7 was on the inside of my triangle. When I'm finding perimeter, I'm finding the distance around the outside. So I don't even use that 7. I use the 9, and the 10. So sometimes in a picture, they'll give you more information than you really need. So you have to decipher what's important to you at that time and during that problem. So also just another note, it says S1, S2, and S3. Those are just little subscripts to help you figure out that these do not mean, these are not representing the same side. So it's just to help you decipher, hey, there's 3 different sides there. I need to take them all into account. So once I fill in my formula with my values, I just add them all together and I get 28 yards. Parallelograms. Parallelograms look like a slanted rectangle. And so I've got a few of the same properties of a rectangle. I do not have right angles, but I do have my 2 congruent opposite sides. So that's important. And then I've got this drop down height like I did up here in the triangle. So a parallelogram has some properties or characteristics of a triangle, some of a rectangle. So that's why it's important to understand, how these shapes all fit together. So the important information we're going to use to find the area of a parallelogram is just its base and its height. That's all we do. We find the base, we find the height, and we multiply them together. So what makes this a little bit more challenging than solving for the area of a rectangle is that I've got it's tilted, so I have to find the height. And just like the triangle, the height is through the middle. It's got that drop down bar, dotted line or solid line sometimes, but it's always going to make a right angle with the base. That's how you know. So if I'm using this picture down here, I've got my base is 13 and my height is 7. So that's what I'm going to use, 13 times 7, and I get 91 yards squared. To find the perimeter, again, it's not really a fancy formula, but it's just all the sides added up. In this case, remember, it's all the outside sides, all the outside values, not the one on the inside. That one doesn't count for perimeter. So on my picture, I've got 13 yards, and this would be for 13 yards, 11 yards, and 11 yards. So that's what we got all together, and that's going to end up with 48 yards altogether. And then last but not least, we've got trapezoids and circles. Trapezoids are even funnier looking than the parallelograms to the triangles. It's sort of like a parallelogram because it's got two parallel sides, but instead of having them slanted in the same direction, the other sides are slanted in opposite directions. So it's an interesting shape, and it's got a very interesting formula. I've got a lot going on here. To find the area of a trapezoid, you take 1/2 times the quantity of base 1 plus base 2 times the height of the whole object. If you look over here at my two different trapezoids, you'll see my bases are the two parallel sides, base 1 and base 2. There's really no difference if I labeled them base 1 up here and base 2 down there. That's okay. But that's what I'll use, and I'll add them up, and that is considered my entire base. So I'm going to use those two numbers plus, again, my drop-down height from in between them. So that's the information I need. So I look at my picture with all my values. I've got 5 different numbers here to choose from. The only numbers I need are the two bases, and again, you'll know the two bases because they're parallel to each other, and then you'll know the height is connecting them, and it's forming a right angle. So those are the 3 numbers I need. So I take my area equals 1/2 times the quantity of base 1 plus base 2. So I just wrote that down. Then I close my parentheses, and on the outside I'll write the height, 4. Now again, you'll have to follow the order of operations to solve this problem. You go to your parentheses first. Inside the parentheses, I've got to add. 10 plus 5 is 15. Now I can finish out my problem. I'll probably multiply 15 times 4 first and get 60, and then half of 60 is 30. So it's area, so I have to put my meters squared. Perimeter, again, it's just adding up the outside numbers. So I just add 7 plus 5 plus 7 plus 10. And in that case, I'll get 29 meters. Circles. Circles are so different than any other shape we've talked about. The reason is because they've got a curved edge. So with a circle, we've got 2 things. We've got radius and we've got diameter. The diameter goes all the way through your circle, and it goes through the center of the circle. The radius only goes through half the circle. So the radius is worth half of the diameter. Or it takes 2 radii to make 1 diameter. So that's an interesting characteristic about circles. The other thing we need to know is that pi, the symbol pi, equals 3.14. We're going to just truncate it right there. We're only going to use 3.14 for our calculations. So the formula for finding the area of a circle is pi r squared. So we're going to take the number pi, which we said was 3.14, and we're going to multiply that by the radius squared of the problem. So in this case, in my problem here, my radius is 9 inches. So I replace my formula, I replace the r in my formula with 9, and I'm going to multiply 3.14 times 9 squared. Now the first thing I need to do is square my 9 to get 81, and then I'm going to multiply 81 by 3.14. And this is what I get. Don't forget your units. Area is always in square inches, or square units. Lastly, I'm going to scoot this over a bit. Lastly, I'm going to talk about circumference. Circumference has 2 formulas, in a sense. Some people say circumference could be found by multiplying 2 times pi times r, which is very similar to our area formula. It's not the same, but it uses the same symbols and letters. Or you can use pi times the diameter. The reason you can use either or is because, like I said before, one of these diameters is equal to 2 of the radii. So either one of these formulas will work to finding you the correct answer to your problem. I normally, I always have an opinion. I prefer this one over here. Circumference equals 2 times pi times r. The reason I like using the formula with the radius is because later on, when we talk about different 3D shapes, like cylinders, in 7th grade you'll do cones, stuff like spheres. Anytime we use those, we're learning about those 3D objects and we're trying to find volume and whatnot, you're going to use a formula with a radius in it. So I typically stick with the radius because I feel like the only time I use the diameter is to find circumference. So later on in math, you won't really be using the diameter all the time, so I stick with this one. If they ever give you the diameter in a problem, you can just cut it in half and there you go, that's your radius. So I like using this one instead. So what I did was I took this formula and I plugged in my 9 where r was. So now I have 2 times 3.14 times 9. Well, in my head, I'm like, well, it's easier to multiply 2 times 9, and I did, to get 18. If I used this formula up here, this is what I would have gotten anyways. Then, once you get to this number, you've got to continue multiplying and continue simplifying your answer. So, all in all, my circumference of this circle is 56.52 inches. I hope all of this made sense. Again, you've got to memorize these because you're going to be using these over and over and over again. All right, I'll see you later on. Have a good day.